2, 1. Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Ben, who has completed one of our courses, ROS2 Navigation, in 5 days. And at the end of this course, you can present a project, which is what we'll see today, of a real robot running an autonomous navigation stack from the open source project nav2, and actually build an application on top of that to do some autonomous navigation. So that's what we'll be seeing here today. So hello, Ben, how are you?
I'm doing great. How are you doing?
I'm good. Happy to see you here again and excited to see your next presentation about ROS2 navigation. So yeah, please go ahead and tell us how you've done your project.
Awesome. Yep. So this is going to be my presentation slides, and then we'll get into the demo that I have in the real robot.
Great.
So a little bit about me. My name is Ben. I'm a Master of Science student in aerospace engineering at the University of Houston with my study focus in control systems. Some of the contents I'll be talking about in this presentation: the map server, localization of the robot, the spot recorder script that I created, the path planning for the robot, the action client server, obstacle avoidance added to the robot, and then some of the things that I ran into and some of the hurdles I had to go over. So starting with the map server, using Cartographer to create the 2D map, and then also using nav2 Lifecycle Manager and the nav2 map server in a launch file so that you can see the map in RViz. To the right, that is the map that I ended up creating for this project. Next, for localization, we have to set up AMCL for the map server to localize the robot with the 2D map. We use a 2D pose estimate so that AMCL can then communicate the transform between the map and ODOM. And then the new AMCL node will be added to the launch file so that they can launch together. And then this is a visual of the robot being localized before any movement. So you can kind of see this particle cloud is quite large, but as the robot moves around, this particle cloud will then be more centered on the robot's path. So for the spot recorder script, I'm initializing a node called spot recorder, and I set up a service called save spot for saving all the spot positions that I want to, and it subscribes to the AMCL pose topic for the robot's pose messages. It handles incoming service requests by queuing the robot's position data if it's unavailable. It won't save spots, and then for adding spots and saving all of the spots data for the .yaml file. And then just continuing on with the recorder script, I have it saving as a dictionary. I found this out kind of the hard way. I used to save it just kind of brute forcing it to be tabbed correctly, and I found out the hard way that extracting data from that kind of brute force method was extremely hard. And then I later found, okay, if I set it up as a dictionary, retrieving the data from it as a dictionary is a lot easier and more straightforward that way. So yeah, it sets move to spot and then ROS parameters, and then I have labels for each new spot that I call upon. Once I call the service, it knows to add on with the spot labels, and then the orientation of the Z, position of the X, position of the Y. And for the path planning system, we have to add all the config files for the controller server, planner server, recoveries, BT Navigator, and then launch all of those new nodes into one launch file as well. And then this is going to be the action client. I set up the node move to spot, and it creates an action client for the navigate to pose action. I load all the spots data from the spots.yaml file, and then it constructs a goal message using that given spot data, and then I can call upon the action client to move to the given labeled position. And then also adding some obstacle avoidance to the project. I added a global cost map and a local cost map. So now that the robot can avoid those random objects given any real robot environment. Obviously, the simulation is the same every time, but for the real robot, you can have, I've had obstacles in the corners that the robot's supposed to go to. So, you know,
Yeah.
any sort of avoidance is necessary for this. So yeah, some of the complications I ran into, ensuring that every instance of base link is then changed to base footprint, switching from the simulation to the real robot. Also adjusting the inflation radius to the correct size of the map for the global and local cost maps, because initially it's really large and the areas that are safe aren't very defined once the radius is too large. So you kind of have to work back and forth to make sure that that's correct. And then also, like I mentioned before, understanding to create the spot.yaml data to be a dictionary, and how I can extract data from that to correctly send the right position data.
Mm-hmm.
So let's get into the running of the code. Oh, I'm sorry if you hear that.
Don't worry.
So let's go. I want to pull up the most important codes.
Okay.
There, and the spots. Okay. And I'll let the code run first, and then I can bring this up a little bit larger
Mm-hmm.
and show what's going on there. So let me just, oops, go. All right. All right, so I'm gonna have, oh wait, before I do that, let me localize the robot with the 2D pose. So it looks like it is at the top facing
Looking up, I
this
think.
way. Yeah,
Yeah.
we're about right there. So I always had an issue
Mm-hmm.
going from the sim to the real robot. I do have every instance of base link going to base footprint, but for some reason my cost maps, they never receive the map, but they still work for
Yes.
obstacle avoidance.
Yes, correct. So that's actually I'm gonna do a comment about the base link, base footprint, but basically that's nothing to do with that. That's basically because of the remote nature of this. So RVS for some reason has trouble displaying the cost maps, but it doesn't mean they're not there. Otherwise,
Right,
your application wouldn't work because they'll be like,
right.
"Where are my cost maps?" It's just RVS's inability to show them. So yes, it adds
Okay.
that little bit of a complication.
Okay, I see. Yeah, because like I said, it still does the obstacle avoidance
Mm-hmm.
fine, but it just never shows them on the on RViz.
If you were actually to
Okay.
do ROS to topic echo of your global cost map, you would just see the numbers. Because it's the message
Ah,
in there. It's just RVS can't see it for some reason.
okay, I see. Alrighty, so I'm gonna move to corner one first, and we will see.
Oh, nice. I like that you didn't sort of moved it around. You kind of left it up to the controller
Yeah,
to
let it
do
figure
it.
it out.
Yeah, because because it was good enough. So that was nice. So these are
Yeah.
spots that you've saved previously, right? That you've done
Correct.
previously.
And I can, if you want, if we have a little bit of time, I can move it to random spots and then save some new spots and then
Oh,
send it to other locations if you would like
that'd be
to.
super nice to see.
Alrighty, so we got corner one. Now we'll send it to corner two.
Nice, nice. And I also see that it doesn't replan a lot. So because usually it's like when you do the default, it also is replanning all the time because it's harder to find the path that's optimal, especially in a map like this that's very
Mm-hmm.
symmetrical. So I really like that. It's really nice. It means that you spend your time touching those YAML files to make it smooth.
Correct, yes. And then last but not least, we'll do pedestrian.
And you can see there that the one on the bottom right, the obstacle is a little bit out of place. You actually made
Mm-hmm.
this is actually the simulation map, which is nice because
Mm-hmm.
it means that it's close enough that you can use it in the real one. And it noticed
Correct.
this that it's out of the way, so the dynamic obstacle local planner catches it, goes
Yeah,
around a little bit.
exactly.
That's nice.
Yeah. Yep.
All right. So yeah, I mean, we do have a little time, so I'd be really interested to see your spot recorder, and I also
Sure.
have some comments about. I'll do it later about your complications about your dictionary in Python. I'll tell you a
Yeah.
couple of things. Yeah.
Alrighty. So the nature of my recorder script is once I file the spots that I want, I send an end comment to it. I send a label saying end, and
Mm-hmm.
then it saves that, it dumps the data. Um, I also have it set up where once I'm recording data, it'll not stop until I send that end, so I can have, say, for instance, I start with corner one, then I can send corner two. It'll then populate to corner two live. Then I do pedestrian, it'll pop it in. Then I send in, it'll save. But now, with the nature of how I have it set up, if I go to a new spot, it'll start with a new file.
Right. It will
It'll
delete it.
start over,
Uh-huh.
um, which, I've showed corner one, two, and pedestrian, so
Yeah.
it's okay, but I just wanted to let you know that how I have it set up, it
Mm-hmm.
will start with a new file.
Okay. Okay. So here you're
Alrighty.
just gonna move it to a different spot so you can then
Yeah,
run that server.
yeah.
And it's a
So let's
service
see.
server, right? The spot recorders.
It is,
Okay.
yes. The spot recorder is a service. Let's do something interesting. Let's try to. Oh, whoa, whoa, whoa. Oh, I think because this is still going, let me stop this.
Oh yeah, maybe.
Wait, no, it says goal succeeded, so it should be okay to move about. Yeah, it's okay. Let's do something interesting. Let's see if it can figure
Oh, that's nice. Yeah.
stuff out like here. And then we will call this.
So that's running already. So you can just call it, right?
It is, yes. So
Okay.
I should mention that for my navigation launch file, I have the spots to file script node launching. I have all of the nodes for AMCL, map server, everything launched at the same time. Can better show it here. So I have the map server, AMCL, controller, planner, behaviors, BT, lifecycle manager, and then I have my action client and the service
Mm.
running at the same
Okay.
time, so I can call on any of them
Hmm.
while it's running. Okay. What should we call this spot?
I
Middle?
mean, whatever you want. Yeah, middle.
Call it mid. And then you will see that here it
Oh, yeah.
starts over and then it saves the spot.
Cool.
And then maybe we can do maybe one more. let's do that. Maybe do it, we'll do it at the top in the middle.
So then, that's cool. So then technically, you don't need to do the end, right? Because it outputs the file, right?
Correct, yeah.
Mm-hmm, mm-hmm. That's actually better, yeah.
And then top, yep.
Okay,
And then
nice.
now I can go ahead and let's call on that mid spot. And it should, I can maybe minimize this so we can see it.
Uh-huh.
Go to the mid spot.
Yeah, yeah. So that save reporter, oh look, wow, that's
So did
might
get
have a
close.
little bit of an issue. So right now maybe it's,
Yeah, I think it's into one of the recovery modes right now.
is this your controller? Oh. What is that? Oh, that's just the output to your safe spot, right?
Correct. Let's see. Maybe let's give it a 2D goalpost to kind of
Get out of
move
the
it
way,
a
yeah.
little bit.
Yeah, I think it's sort of getting stuck somehow with either an inflation radius or something.
Yeah, I think it is the inflation. We can get it out of the way a little bit.
Yeah, it doesn't record all the time your
Thing.
commands.
Okay.
We're working on that.
Let's have it here. We'll brute force it out of the way a little bit.
So maybe it will automatically. Is your path still trying to go or?
Let's see. I think it might be. Yeah.
But I think something probably. So
Yeah, I
you
think
should
it's
try it
hung up.
again, maybe.
Let me see if I try to send it one more time. Let's see if it retries. Oh, wait.
Oh, you
Oh,
saved the
no.
spot.
I
Right?
just said, oh,
No, don't
no.
worry. Don't worry.
Oh,
Maybe
man,
get
I'm
it out of the
sorry.
way there. Just moved it up a little bit, and just send it back. We're just trying to showcase all the cool stuff your program does.
Right.
So now
Okay.
your mid is very similar to your top.
The top,
Right?
yes. Yeah, let's go ahead and redo that.
So from here, you can just call any of those two, and
Yeah.
we should see because we just saw you create those spots.
Yeah. Oh, it wasn't this one, it was this one, right? Yeah. So let's do top instead since we're a little further.
Yeah. Yeah.
Yeah, I think the inflation could be a little bit higher.
Well, yeah, and there's a little bit of an added complication here because the robot is actually seeing that stick, not the bottom base of the obstacle. So a lot of the times, our students will say, "Oh, maybe my inflation rate is not working." Well, no, it's just because
I didn't even think about that.
yeah, because it's not gonna see the bottom. Sometimes it graces against them, but that doesn't mean it's not working. That means it should be a little bit more. So it's a balance because this map is very small.
I did not even think about that.
Great, and now
Oh yeah, and the mid's right next.
right
I
next
forgot.
to it. But hey, we saw it in action, so that's an added thing. So awesome, Ben. Really nice job. Let me give you an applause. Congratulations. It's a
Thank you.
really straightforward and really understandable presentation. I really liked how you showed us live an extra of how to save a couple more spots, and also I really liked how you were saving them, and automatically you would see the addition of the spots in the YAML file. which actually, like I said, removes the need. Like we did it thinking, oh, at the end, press end and it will create the file. Well, no, you did a step further and it's creating it kind of on the go, on the fly. So that was really nice
Yeah.
to see. And so I got a couple comments. So first, I noticed that you said you use the AMCL post to save the spots, and then
Mm.
you mentioned in case it's unavailable. So do you
Mm-hmm.
actually know why sometimes it is unavailable?
Um, it's you have to have the 2D pose estimate to start up AMCL, correct? So if you're not doing that, then the code will not run because it's not the 2D pose estimate gets AMCL booted up and running,
Yeah,
correct?
that's correct actually. It's not completely necessary because there's a service called global localization that basically
Mm-hmm.
just all those particles we're seeing spreads them out. And we talked in our previous presentation about a way to localize your robot, and I just move it around because I
Mm-hmm.
can't tell it. So yes, that's correct. But the actual reason uh, AMCL pose, like I'm sorry, AMCL node, the node, it only publishes the pose, AMCL pose, when it's moving. So it needs to actually take in the lidar, the change between the lidar and the odometry in order to publish that extra one. So you probably were trying to subscribe to it, but no new messages were coming in. Like, all right, so I'm gonna have to wait until they're available, maybe. And so then once you start moving it, and you're again, if you're echoing the topic of AMCL post, you start seeing those messages come in. So
Ah,
that's one reason. Um,
okay.
yeah. Another thing I thought it was interesting, and you probably saw this in the forum about
Mm-hmm.
the base link to base footprint sort of issue, and
Yes.
this one is actually not needed. This is actually an issue of remote connections with ROS and the inability of not inability, but the sometimes the static TFs get a little bit of trouble transmitting over the wire because the static TS, which means it's the base footprint to base link to the LiDAR frame, all the ones inside of the robot, those are static. And ROS2 only publishes those messages once, the TF static, because it doesn't make sense, right, to
Mm.
just keep publishing the same info. So they just do it once. So the reason why we say that is because if for whatever reason you connect to the remote robot and that one message doesn't come through, and you're using the base link, that means it's gonna have to know the connection between map, atom, base footprint, and then turn into the static to base footprint, base link. Base link is the
Mm.
center of mass. Base footprint is just the projection of the center of mass on the floor, and so that's the first. The base footprint is usually the first static TF of the robot. So since we select that one, then sometimes it will create problems, and that's why we suggest just do base footprint because it'll just look at the dynamic TFs, which are
Mm.
the ones that are being published. For example, for AMCL is publishing map to Autumn, and then just the robot state publisher is then publishing from Autumn to your base footprint. So that's the actual reason why you probably won't experience this unless you're working with remote applications. So I just wanted to mention that to have it clear.
Yeah, that makes sense because I made the change for the real robot, but then I used it in the sim and it still worked in the sim
Yeah,
as
exactly.
well with
Because
both
mm-hmm,
the frames.
mm-hmm. So for
Yeah.
navigation, if I'm running the nav, because right now you're running your navigation nodes, and then
Mm-hmm.
on your on the construct, which is wherever you are in the world, and then the robot is in another place in the world. It's actually running the TF, the autumn, the scan that is needed, and that communication sometimes fails. So if you do it all together, that's why it always works either in the sim or the real robot. if you select base footprint. Yeah. And then
See.
I wanted to make one last comment that you mentioned, that it's really hard to read that file spot in order to then send it over to the action client.
Yeah.
So you're actually using Python, right, to read
Mm-hmm.
that file and then just then shove it into the values of your navigate to goal client, right?
Yep.
Okay. So there's that's why it's hard, and there's an actual easier way to do it, and it's actually uploading that YAML file as ROS2 parameters, right? So if you check any of the YAML files for your navigation file, you'll see that they're actually ROS parameters like you wrote in your spots YAML. But I think there's an actual error in your spot file, and it's ROS underscore parameters, and then dot dot. So if you for example, open up, you see line 2 is underscore, and if you go to, let's say, your controller.yam at the bottom of your tree right there, you see how it's got 2 underscores. So the reason they do this is because you can then upload these as parameters to the ROS2, let's say, ecosystem, right? So then you can load these parameters up. You can do it either through your command line ROS2 param load and then the name of your file, and those get stuck in your ROS2 session. So whenever you want to access them, you could do, I think it's get parameter, and it's really simple, because then you don't have to worry about how to go line through line or whether it's a dictionary or not. It's a ROS2 parameter, so you can do, in this case, get parameter mid dot orientation or dot position, and then it would access that value. So it's an extra.
That's crazy that you even saw that this was a single.
I'm very used to it. I've just run into the same issue a lot of times. But this makes your life a lot easier, and it's very useful as well, because you can actually load up parameters at runtime, right? So you can just have them there, and based on different changes on your robotics programs, your applications, you can then load another parameter to alter the behavior without having to do that extra work that you did. That was like, how do I access this X position, this Y position, just with Python? So I wanted to mention that, so you take a look at how ROS2 parameters work. It's just in the RLC Py library, the ROS Python library, and it's very useful, and it can save you a lot of time for that. So I recommend you check that out.
Yeah, I definitely will.
All right. But yeah, that ROS, that's why I noticed, that's how I noticed, like, that's missing an underscore. So if you do that, then you can do load parameters, get parameters. It's just a little bit different, but it'll save you a lot of time and headaches. So I recommend you check it out. All right. Yeah. Okay. Well, then that is it. So congratulations, Ben. Really, really nice presentation again. So
thank you very much.
All right. Yeah, cool. So yeah, guys, this is what you can do. Let me just switch back to me here. Yes, this is what you can do when you complete our ROS2 navigation course. You can actually apply autonomous navigation onto a real robot, and then build an application like we saw here. We saw in real time how Ben would record a spot anywhere in the map of a known map, and then you can use the client to just go to that spot. This is actually done in many, many applications right now. So it's something you can learn in our course and apply it to your real robot. So I invite everyone to do what Ben did here and come present your learnings. So yeah, guys, that's it for us. Thank you, Ben, one more time, and we hope to see you again for your next presentation.
Thank you so much.
All right, guys. We'll see you guys next time. Okay? Bye-bye. All right, cool.